Part 8, adding and subtracting fractions with different denominators. Now here's where all of our reviewed skills can be used. Let's try 4/15 plus 5/18. It's now showtime here, everything that we've learned. The first thing we're going to do is look at the two denominators and find a common denominator between them, 15 and 18. 15 is 3 times 5, 18 is 2 times 9, which is 3 times 3. So what we're going to try to do is find a common denominator between the 15 written in pieces and the 18 written in pieces. And then our common denominator, there's 1, 2 here, no 2's here, so we have 1, 2. There's 1, 3 here, 2 3's here, so we have 2 3's. 1, 5 against no 5's gives us 1, 5. This is my lowest common denominator. If we want to see what that looks like in numbers, 2 times 5, I'm not going to get caught up in this one again. 2 times 5 is 10, 3 times 3 is 9, 10 times 9 is 90. Now, there's a couple ways of doing this. We could either know that we're going to get 90 as our common denominator, or we can just use, and I'm going to do this in red now, where this is what I want this 15 to become, as well as this 18 to become. So let's look at the pieces that make up 15. That's 3 times 5, 1 3 and 1 5. Let's look at the pieces that make up 90. That's a 2, 2 3's, and a 5. Now I'd like to make this thing, 3 times 5, look like that thing. Now if you look not even very closely, you just have to see what's missing. Can you see that there are no 2's here, and yet there's 1 2 at the end? So this is missing a 2. It's also missing 1 3. We started with 1, we're ending with 2, so we must have picked up a 3 along the way. It has the other 3, and it has the 5. So we're missing 1 2 and 1 3. And 2 times 3 is 6. And that is the missing number. If I multiply this denominator by 6, I will have this final answer of 90. But as before, when we learned about building fractions, if I do it to the bottom, I must also do it to the top, because I want to multiply by a fraction that equals 1. Now before I multiply that, let's continue with the problem. I'd like to make 18 look like 90 as well, but these are the pieces that make up 18, and these are the pieces that make up 90. I start with a 2, I end with a 2. I don't need any more. I start with 2 3's, I end with 2 3's. I don't need any more. I start with no 5's, I end with 1 5. Can you see that this is missing a 5? If I had a 5 stuck in here, it would look just like what I want it to look like. So that's what that number 18 is missing up above. If I multiply it by 5, I will have that desired 90. If I do it to the bottom of the fraction, I must also do it to the top, so I could multiply this fraction by 1. Now let's see what this fraction becomes. The original fraction is 4/15, but if I multiply the top by 4, I get 24, and 6 times 15 is now 90. As before, I am changing the appearance of 4/15 without changing its value. Now on the second fraction, if I multiply 5/5 times what 5/18 is, I end up with 25/90. Can you see, in this form I cannot work the problem with different denominators. However, with common denominators, the problem becomes easy. So my answer is 90ths. I have 24 of them plus 25 of them makes 49/90. Now that would be my answer unless I can reduce it. As you can see, the only number that will divide into 49 is 7, no 7s in 90. We already know that 90 is made up of 1, 2, 2 3s, and a 5. So no 7 will divide into the top or bottom. Therefore, there are no numbers that will divide. This number is reduced to its lowest terms, and this is the final answer. Let's try another problem, but now let's subtract our fractions of unlike denominators and see if we can get an answer. As we have over here done before, we're going to take the 20. We first need to find a common denominator. The 20 can be broken up into 10 times 2, and 10 is 2 times 5. So 20 is 2 times 2 times 5. And that is its factors. And the 36, I don't want to go too low here. The 36 is 6 times 6. The 6 is 2 times 3, and that 6 is also 2 times 3. So we have 2 2s and 2 3s. So these are the pieces that make up 36. Now what I need to do is play the factor wars. This has 2 2s, this has 2 2s. My answer will have 2 2s. No clear-cut winner, but the majority has 2 of them, so we have to write them down. This has no 3s, this has 2 3s, so I need to write those 2 3s down. This has 1 5, this has no 5s, so I must put that 5 down. Now we're getting a little tougher here, because lots of numbers to multiply. I could, if I want, make 2 times 2 4, 3 times 3 is 9, and here's a 5. And let's take the 4 times 5 and make 20, and then take the 20 and multiply it by 9, and that will give me 180. Now 180 is my lowest common denominator between 20 and 36. However, I'm going to use the pieces. The pieces will never fail me. But with the 180, I know many of you were taught to take this 20 and divide it into 180, and take this 36 and divide this into 180. But of all of the operations that you have, division is the toughest. And to just make the observation, what's missing, that should be pretty easy. So these are the pieces that make up 20. These are the pieces that make up 180. How do I make the 20s look like the 180s? Well, the 20 has 2 2s, the 180 has 2 2s. We don't need any more. The 20 has no 3s, the 180 has 2 3s. So if I had 2 more 3s, I'd have what I would like from the 180. As for 5s, we start with 1 5, we end with 1 5, and we don't need any more. So the only thing that's left are these 2 3s, and 3 times 3 makes 9. And magically, if you multiply these out, you'll notice that you get 180, but we'll do it simply, just by observing what's missing. If I do it to the bottom, I need to do it to the top, so I can preserve the value of my fraction if we multiply it by 1. Now let's try with 36. How can I make it look like 180? Well, I have 2 2s to start. I end with 2 2s. I don't need any more. I have 2 3s to start. I end with 2 3s. I don't need any more. Here I have no 5s, and yet I picked up a 5 along the way, so I'm missing a 5. So if I multiply this 36 by 5, then I should have exactly 180, and I'll let you work that. But if I do it to the bottom, I must also do it to the top to preserve the value of 5 over 36. Let's go back to blue. Now what I'm left with is 9 times 4, or 36 over 180, minus 5 times 5, which is 25 over 180. Now that we have common denominators, this problem should be very easy. My denominator of the answer is 180. 36 minus 25 is 11. And 11 happens to be a prime number, and 180, which looks just like all of these things here, that 180 doesn't have an 11 in it, so you can see that 11 over 180 is my final answer. Let's try another problem. 8/35 minus 5/50. And by the way, if any of you feel competent enough to try to do this on your own, you can simply freeze this lecture and then see what you get, and then play my recording and see if you do get the same answer that I do. So let's try it. Here is 35 as a denominator, and here's 50. We first need to find a common denominator. So let's take 35 and 50 and break them up into pieces. And to factor, 35 is 5 times 7. Pretty easy one. And although the factors are getting bigger here. And 50 is 10 times 5. 10 is 2 times 5. And 5 is its own prime number. So the primes that make up 50 are 2 times 5 times 5. Now, what I'd like to do is play the factor wars again. We want to find out which one has the most 2's. Pretty obvious, 50 does, and it has 1 2. Then we'll look at the 5's. 35 has 1 5, 50 has 2 5's. So we'll take these 2 5's. And as for 7's, there's no 3's. You notice that we're missing 3's, so we skip them. We don't have to have a representative from each of the prime numbers. We just have to have the most of each one that's represented. So here's 1 7, and here's no 7's, so my final pick will be 7's. This is the common denominator of 35 and 50. It's the least common multiple in some books that will serve as the common denominator. Now, if I had to multiply these together, what I would do, I think, would be to multiply 2 times 5 and get 10, and 5 times 7 and get 35, and 10 times 35 is 350. Huge number, scary number. But I have confidence we'll be able to do it. Now remember, we want to find out how do I build 35 into 350. I think we can all see that all we have to do is multiply by 10, but don't do it this way. Please don't. The thing about math is to develop a rhythm, and once you know that every problem is going to be broken up, every denominator is going to be broken up into pieces, and then we'll find a common denominator in pieces, then all we need to do is look and see what pieces are missing. In this case, let's go to red. In this case, it's a 2 times 5. However, if you can merely look at the problem and get an answer, then you're doing some problems some way and other problems another way, which means you have two methods to think of in your brain. And your brain has got a maximum capacity. And if you want to make math hard for you, for yourself, then you do it in several ways. But if you want to make it easy, you do it the same way every single time. And in this case, we're missing a 2 and a 5, which makes that 10 that we knew would show up, but thanks for humoring me and playing the game. Now we want to make 50 into 350, and we could probably guess that that's a 7. However, these are the pieces that make up 50, and these are the pieces that make up our final answer, 350. Now, it has 1 2. We are only looking for 1 2. This has 2 5's. We're only looking for 2 5's. This has no 7's, and we're looking for 1 7, so we need to pick up a 7 along the way. So as predicted, there's that 7. But remember, I'd rather do it by the process that we've already established, not by guessing. So if I multiply the bottom by 7, I need to multiply the top by 7, so we're multiplying this fraction by 1. Similarly, if I multiply the bottom by 10, I need to multiply the top by 10, so I multiply this fraction by 1. What we have left is 8 times 10 is 80 over 350 minus 35 over 350. Now, this may become troublesome because we have a big denominator and we don't know what we'll get in the numerator. 80 minus 35, it doesn't mean defeat if you do this off to the side, so this is a 7, and 3 from 7 is 4, so I get 45 all over 350. Now 45 and 350 appears to look like, well, there's a 5 and a 0. We know it's divisible by 5. But let me do something clever. I'm going to take 45 and I'm going to break it down into 9 times 5, and I'll break this 9 into 3 times 3. So 45 is 3 times 3 times 5. And 350, we know from this right here that it is 2 times 5 times 5 times 7. Now, let's see, the 3's will not cancel, but I do see a 5 here. We'll cancel with this 5, and I get 3 times 3, which is 9, divided by 2 times 5, which is 10, times 7 makes 70, and that should be my final answer. Now, if I wanted to take 45 and divide 45 350ths, we know that we could divide top and bottom by 5, and I'll bet you we get the same answer of 9 over 70 as my final answer. What if we were asked to add mixed numbers as we see here on the paper? 5 and 5/6 plus 2 and 4/15. Notice that this is written in a vertical format as opposed to the horizontal format that we have been working with in the past. First, I must get a common denominator for the 6 and the 15, because we cannot add fractions without having a common denominator. As before, we will break these things up into factors, and once we have factored them, these things right here, we'll have our factor wars. As you can see, we have 1, 2, 1, 3, no clear-cut winner, but we have 1, 3, and 1, 5. If I multiplied this out, 2 times 5 is 10, times 3 is 30. That will be our lowest common denominator. However, we've already established the pattern, and the pattern is, let's start with what we have factored and see how many factors we need to add to it. If you look at this and look at this, you can see that a 5 is missing. If I multiply this by 5, I also need to multiply the top by 5 to preserve the value of 5/6. What I'll get is something different. Actually, I'll get 25/30ths, but it is still equivalent to the original fraction. Now remember, I'm still continuing to see what's missing in order to work the problem. I'm not guessing at how do I make 6 look like 30. In a similar way, I want to make 15 look like 30, and yes, I could guess at it, but 15 is made up of 3 and 5, and this is missing a 2. So by looking at the 2, by multiplying the denominator by 2 and the numerator by 2, we should be able to build this fraction up into 30ths, which we can. 2 times 4 is 8. Now, once we have a common denominator, we should be able to add them. 25 and 8 makes 33, and our common denominator of 30. The whole numbers are easy. 5 plus 2 makes 7. Now, unfortunately, we have a little concern here. This number here is an improper fraction. There's nothing wrong with using an improper fraction, but the 7 makes it wrong. You can't have mixed numbers and improper fractions in the same problem. So since we've already got a mixed number going, let's try to make 33/30ths into a mixed number. And I can do that simply by dividing, and what I get is 1 and 3/30ths left over. And we can add that to the 7 that's already leading our problem. 7 plus 1 is 8 and 3/30ths. Now the only thing left to do is to make sure that our fraction is reduced to its lowest terms, and as you can see, both the numerator and denominator is divisible by 3, and our fraction can be reduced to 1/10. And our 8 is unaffected out in front, and our final answer would be 8 1/10. I mentioned earlier that it was easy to pick out what's missing from a series of factors as opposed to dividing. In a similar way, addition is easier than subtraction, but sometimes we have to face the music, especially when we have a subtraction that may need borrowing. Now, I don't know if that's the case here, but let's see. What we're going to do is, just like before, this is written in the vertical method. So what I'm going to do is take the 12, which is 2 times 2 times 3, broken up into factors, and the 8, and that's 2 times 2 times 2, and see if we can find a lowest common denominator between them. This one has 2 2's, this has 3 2's, so the 3 2's will win out. This one has 1 3, this one has no 3's, so 1 3 will win out. Now, 2 times 2 is 4, times 2 is 8, times 3 is 24. Now, 24 will be our lowest common denominator, but as before, let's look at the factors. I can give you big, ugly numbers to make sure that you use factors, but try to practice them when they're easy, because no matter how big and ugly the numbers get later on, it will never be any different in terms of difficulty. If you try to do this mentally, you're going to lose out, and I've seen lots of students lose out over the years. So try to follow the process and don't deviate. 2 times 2, there's 2 of them. Here's 3 of them. I'm going to need 1 more. So we need to multiply by a 2. Here's 1 3. Here's 1 3. So we don't need any more. So all I'm doing is missing the 2. Once I make that observation, I multiply the bottom by 2 to make 24, and then whatever I do to the bottom, I must do to the top, and this now becomes 10 over 24 instead of 5 over 12. Now, in a similar way, I'll take the 8, which has 3 2's, and I'll compare it to what I'd like it to be, and I'm missing a 3. And if I multiply by this 3, then if I do it to the bottom, I need to do it to the top, because I want to multiply this fraction by 1. And what I get is 21 over 24. Now that we have a common denominator, we're halfway there. However, 21 24ths cannot be taken away from 10 24ths. We don't have enough. So what we need to do is go to the 15 and make it into a 14. I'm going to take 1 away from that, and that 1 is going to move down here. So let me rewrite the problem down below, and what I get is 14 and 1 and 10 24ths, and I want to subtract 8 and 21 24ths. Now I have enough room. Can you see that all of this is a mixed number, but if I put it together as an improper fraction, it will more than compensate for this 21 down below. So 24 times 1 is 24, and 10 makes 34 24ths. Now I have enough 24ths such that I can subtract 21 of them. 21 from 34 makes 13 24ths, and 8 from 14 makes 6. Now that could be our final answer, unless one of two things happens. Is this a number that can be reduced down, a fraction that can be reduced down? Well, no number will divide into top and bottom evenly, and as you can see, this 6 and 13 24ths is my final answer.